Welcome. I'm Debbie Gordon, Senior Principal at RMI in the Climate Intelligence Program. We're very pleased to have you here joining us today to showcase the Oil Climate Index Plus Gas, or OCI Plus, to discuss its findings, functions, and use cases for climate action. A couple of housekeeping notes before we start. We are recording this event, but only our RMI presenters will appear. And please use the Q&A function to type in your questions. Here's our agenda for the next hour. Next slide, Rose. Thank you. I will start out with a few slides on the OCI Plus, its history, the underlying models, and some top findings and a few next steps. Then my colleague Rose Wong will give us a quick tour to demonstrate the OCI Plus web tool. We'll have a roundtable discussion with TJ Conway and Fran Royland on the policy and market use cases for the OCI Plus. And then Linda Yoroshkova will lead a Q&A section with you in the audience. So as far as the OCI Plus goes, this is a model that quantifies and compares greenhouse gas life cycle emissions from the oil and gas sector. This spans from production, the upstream portion of the sector, to refining and processing, transportation and storage, and end uses. We use three underlying models. They're peer-reviewed, they're open source, and they're engineering mass balance models. These models have been in use for over a decade, and this whole project actually has a long history, which was first released in 2015, almost a decade ago. These models are, the upstream model is out of Stanford University called OPG. That's the model that does production greenhouse gas estimating. Prelim from the University of Calgary. And then we've developed with Kumi Analytics OPEM, which is the model that estimates the end use of oil and gas, the use of gasoline, diesel, et cetera, all of those fuels. Put together is the life cycle greenhouse gas emissions. The data sources and the inputs to these models are oil and gas characteristics and asset characteristics. Where's the well, how deep it is, what is its pressure, things like that. Activity data, production volumes, whether how operators are actually extracting and shipping these oil and gas products and refining them. And then we also use a host of satellite and remote sensing data that you'll see when Rose demos the tool, and that is a part that will be growing. Next slide. The reason why the satellite intelligence will be growing, and we're very excited about this, is that the OCI Plus estimates what I would call normal operations. This is the type of energy sources that are used to get oil out of the ground, refine and process the oil and gas. And this is emissions from flares and components. But we're seeing, as you see in the slide here, a host of releases of methane, for example, that are large super emitters that are not part of routine operations. These come from events that might happen, an accident, or when there's no maintenance, or a flare pilot goes out. And we are incorporating these data into the modeled emissions in the OCI Plus. So a combination of estimated and measured emissions go into this model. Next slide. My original hypothesis for this project going back a decade was that the emissions would be wide-ranging, which you can see here. These are the life cycle intensities, emissions intensities of different types of oil and gas assets. And that did prove to be true, as you can see, from under 400 kilograms per barrel of oil equivalent to over 1,200 from a life cycle perspective. And I really thought that depending on the chemistry and the physical nature of these assets, they would really differentiate themselves. There I wasn't correct. And you can see the middle dots on these curves, the medium blue dot, you can see an increase in the emissions that goes up because assets are quite different as they are underground and have to be processed. But what's really interesting here is that they do overlap. And so not always is a dry gas necessarily less emitting than an extra heavy oil, for example, depending on how these assets are operated, and which really gives a huge control mechanism to operators, to the industry. Depending on how they're operated, there can be very high or relatively low emissions within the same class of an asset. Next slide. So the last slide showed the total life cycle emissions. Again, that's from extraction all the way through end use, the entire life cycle or value chain of oil and gas. In this slide, I wanted to draw out the distinction of what's the industry's climate responsibility. And so I'm only pulling here the emissions from producing, processing, refining, and shipping, transporting oil and gas, not the end use. But when we look at the industry's emissions responsibility, we see that methane is responsible for just over 1/2 of the industry's total climate impact. And that's huge because this is something that the industry can control, and we'll discuss that later. And just imagine this bar, if all of those dark blue bars went away, the whole entire industry footprint from oil and gas would lower. It would, that gray bar, the remaining CO2, mostly carbon dioxide, would lower down. And there's a huge benefit here and a huge climate opportunity for the industry to reduce its emissions. And next slide. So what are the opportunities, both present and future, that we're imagining here? And this will be a big part of our discussion coming up. We're very excited about increasing operating transparency here. Oil and gas, there is no standard oil and gas. Oil and gas are very different from each other, and the operators can operate very differently from each other. As I mentioned, integrating satellite detected methane is going to be a huge opportunity. We've already started, we'll continue there. We're advancing energy and climate policy, using this climate intelligence, and we're working really hard to align energy and climate markets using this climate intelligence. Right now, markets mostly trade geopolitically. The price of these oils and gases are much more about volumes and geopolitics and not about climate. In terms of looking ahead, we are using these data to update national emissions inventories. We are looking to add new user-based analytics and tools that we are excited to hear from you in terms of use cases to add into the Oil Climate Index plus gas, charting energy transition pathways, and ultimately digitizing these emission transfers so they can be easily monitored and reported. So with that, I am going to turn it over to Rose to demo the OCI Plus. Over to you, Rose.
Thank you, Debbie. Good morning, good afternoon. As you know, OCI Plus was launched in June last year. In this release, we've expanded our modeled field number from 135 to about 600, covering 2/3 of global oil and gas production. We also added a bunch of new features, including 8 years of time series of emissions data. Let's first go to the map page. Each bubble on this page represents one oil or gas resource. The size of the bubble is proportional to the estimated emissions intensities. Users can click on the bubble to read the emissions intensity number and also click View Details to read the oil and gas characteristics of this field. They can also scroll down to see a time series emissions profile. You can see emissions can change over time due to reservoir conditions, operational practices, and geopolitics like a civil war. Let's go back to the map page and turn on the total methane intensity toggle and the methane inventory base map. The methane inventory map is based on the GFA dataset from Harvard University. The yellow indicates high methane emissions. We will update this base map with satellite data from Carbon Mapper when they become available. Methane superemitters are already being observed by satellites in Algeria, Turkmenistan, Russia, and the US. These elevated methane emissions are included in our OCI Plus assessment. Another base map we can toggle on is a flaring map. Gas flaring remains a major climate concern. Each yellow or orange circle represents one flare stack. The darker the color, the higher the flat gas volume. These flared gas volumes are derived by researchers at Colorado School of Mines based on their satellite data, and we include flaring data in our emissions estimates. Next, let's go to the supply chain page. Each bar on this page represents one oil or gas resource. Greens are the oils and yellows are the gas resources. The length of each bar estimates the total emissions intensity in kilogram CO2 equivalent per barrel of oil equivalent, or BOE. In this release of OCI+, we break out gathering, storage, and transport as its own supply chain category, and now we have 4 broad supply chain categories, namely production, refining and petrochemical processing, gathering, storage, and transport, and end uses. The OCI+ results default to 20-year global warming potential. This policy relevant timeframe highlights the near-term potency of methane at 82.5 times that of CO2. Users can toggle to visualize 100-year GWP, which makes methane only 30 times more potent. You can see how emissions estimates would be reduced and climate priorities would change if decision makers picked a 100-year GWP. When users click on methane intensity button, the length of each bar shows the methane intensity in kilogram methane per BOE. A lot of the gas resources jump to the top. This simple switch visualizes how different near-term climate targets are for reducing methane versus carbon dioxide. It is also clear on this page that for oil resources, the upstream production segment is dominating the life cycle methane emissions, while for gas resources, both production and transport segments are dominating because gas leakage in midstream operation is a significant methane source. I would also like to highlight another function on this page, the climate fee toggles. This feature converts emissions metrics into financial metrics. Users can turn on these toggles and input a carbon or methane fee value to cost out financial impacts presented by a carbon tax, methane fee, or other financial mechanisms. Furthermore, users can also slice and dice the data to derive more insights. For example, when we choose a specific region, West Africa, and we turn the climate fee toggles off, we can see how variant the West African oil and gas resources are in terms of their climate impacts, with Cameroon Ikwandu being the highest. Next, let's go to the analysis page. The analysis page plots oil and gas parameters on an XY scatter plot to allow users to explore relationships. I'll illustrate how we can use this functionality to figure out the impact of flaring on upstream production emissions. Let's choose the x-axis to be the flaring to oil ratio and the y-axis to be the production emissions intensity. Initially, you don't see a trend when viewing all the oil and gas plotted. However, if we down select to only include oils, a clear trend emerges. The higher the flaring to oil ratio, the higher the production emissions intensity. This is because flaring is more of an oil problem. For many global oil resources, gas is considered a waste product that operators need to get rid of and burn off. Addressing flaring has not only significant environmental and climate benefits, but also public health benefits because of its negative impact to surrounding communities. There's so much more climate intelligence available on this page, but I'll highlight a few more OCI+ functionalities so that we can start the panel discussion. The newly added Data Download tab allows users to download all data that power the web tool. You can find our methodology, glossary, terms of use in other tabs. If you scroll to the bottom of the page, you can also find link to the demonstration videos and our contact information. Finally, OCI Plus is a major team effort. I would like to acknowledge our OCI Plus team members, our academic partners, the front-end developers, and our funders for making this release possible. Thank you for taking this quick tour with me. With that, I'll turn it over to Debbie to lead the panel discussion.
Great. Thank you so much, Rose. And now we're going to have TJ and Fran talk about use cases in terms of policy and market activation. And I have some questions for you. First to Fran. Methane is invisible and it's a very powerful greenhouse gas. The methane measurement technology space, though, is growing very fast. How does the OCI Plus approach and incorporate this fact?
Great. Yes, I'll start with the second part of that question and just jump off of where Debbie was already describing how we are already incorporating some measured emissions data into our modeling in a couple of ways. One example is with flaring emissions data from the VIIR satellite, which of course flaring can be primarily a CO2 source, but can also be an important methane source if flares aren't operating efficiently or if they're unlit. And I actually saw it already, we've already had a Q&A question come in about the trade-offs between reducing flaring can kind of, if we're not careful, lead to an increase in vented methane instead. So it's really critical to have both methane and CO2 measured, and we are doing that in our modeling right now. Another source of measured emissions methane data specifically that we've begun to incorporate have been super emitters that have been spotted with aerial and satellite flyovers of certain fields and basins that we model in the OCI Plus, for example, in the Permian or in some of the fields in the Middle East and across Russian pipelines, for example. So this is something we're going to continue to watch really closely as constellations like Carbon Mapper launch later this year, because we know that although methane super emitters are rare and they can be intermittent, their magnitudes are so large, on the order of hundreds of kilograms an hour to tons. So they can be a significant fraction of total emissions if you're not counting them. And then the final point I want to make is just more broadly how our team thinks about the relationships between modeled and measured data. So if you look at the OCI map, we model global resources, but data availability isn't equal everywhere. And this really leads our team to think about how modeled and measured data can be complementary and really force multipliers of one another. If you think about how measurement data with technologies like remote sensing could have really good global coverage and help us improve the OCI Plus. By the same token, or on the flip side, they will always have limitations, and we can use modeling approaches to fill in knowledge gaps.
Great. And to TJ, to follow on that, what are the cost and economic implications of methane abatement?
Yeah, this is a great question. If we look at just some of the latest IEA analysis, 80% of methane leaks from oil and gas can be fixed at either a profit or zero net cost based on last year's prices. And yes, last year's prices were quite high. So even at lower prices, that we saw in 2017 to 2021, IEA finds that 50% of leaks can be fixed at a profit or no net cost. So that's a huge opportunity for reducing emissions, and there's strong incentives across stakeholders to make those changes. Furthermore, if you're looking at sort of the marginal abatement cost curve overall, methane abatement options are more economic than most other emissions reduction levers that we have available. And yes, we do have technologies that will emerge over time that can help us address some of these critical priorities. But unlike some of those other cases, we have the technology available today to cut methane emissions, and that's very powerful. So that's why we spend a lot of time talking about the decisive decade for methane. And methane is such an important feature of sort of our near-term decarbonization priorities. And OCI Plus can help us have more transparency on the extent of methane emissions in the oil and gas sector, and therefore the extent of the opportunity we have available to cut methane emissions.
Great. And to Fran, And this gets to a question I think Claudine had in the Q&A a bit too. What types of oil and gas decarbonization related policies does a tool like the OCI Plus point to? Because when you have this type of detailed information, you can really be much more effective at regulating and overseeing this complex sector.
Absolutely. And gosh, there's a lot of ways we could go with this, but I'd say at the most like fundamental level, OCI Plus shows us that different oil and gas resources are quite diverse and wide-ranging in their emissions footprints. And so from a policy perspective, this really affects how you would target emissions reduction opportunities than say if you were treating all oil and gas as equivalent or the same. And I'd say furthermore, it points to how different levers must be pulled to address industry's direct and indirect emissions. So to give an example, in the US, we've seen some historic advances in US policy that's targeting or going to or addressing methane emissions reductions, primarily in the production segment, but in other segments as well. And so we can see, Debbie was showing us how methane is a driver for so many global oil and gas resources. So that will hopefully lead to significant reductions, but it will also require complementary action to address the other parts of the supply chain and the other greenhouse gases, in addition to methane. To give an example beyond methane, there are opportunities to achieve major reductions by electrifying operations. So removing or swapping out combustion sources with renewables, for example. And then the last point I make is a different sort of way of thinking about policy, but it's how to increase transparency about those bits of information that are so important. And global oil and gases are diverse, but at the end of the day, a lot of the information that can reveal what their emissions profiles look like is either just not collected or not made available publicly. So there are policy approaches and even bills that this team has helped introduce that can kind of bring out those critical pieces of information. An example of this, and Rose mentioned it, it's a new functionality in the OCI, is time series, right? So emissions, oil and gas fields don't have the same emissions profile necessarily over time. In fact, the intensity tends to increase with age. So OCI Plus is a tool for thinking about what are those critical emissions related factors, such as age and others that can be brought forth using policy tools.
That's really great. It does point to the ability to know when to decommission, because not all of these assets should remain in operation for, foreseeable forever. So turning this for both of you so at COP26 in Glasgow, the global methane pledge was signed. Now up to, I think, 150 countries have signed on to a 30% reduction in methane emissions from all sectors, oil and gas being a prominent one, by the year 2030. And I wanted to hear from you how you think the OCI Plus will be useful for countries and policymakers considering how they can take action to make their commitments.
Thanks, Debbie. I can start and I'll pass it to Fran. So I'll give us sort of a specific case or example that we're working on right now. So I'm on the steering committee for Methane Guiding Principles, which comprises industry signatories and supporting organizations from civil society and international organizations like the World Bank and the IEA. And signatories commit to meeting 5 principles related to slashing methane emissions and improving emissions transparency. This year, a key priority is advancing global methane reductions. And so it is a program called that. And through that, MGP affiliated organizations partner with individual countries to meet the global methane pledge and advance these principles. And so our team is seeking to advance this program by carrying out in-country workshops, especially with newer producers, to support governments' efforts to better measure and model their emissions, and then institute policies and regulations that minimize and reduce emissions. So OCI Plus is critical in this, both to help understand how to best estimate and measure emissions, and then obviously also institute policies and regulations, and those types of emissions levers that we were discussing earlier, the emissions reduction levers that are available. So that's just one example, but I think it's illustrative of the wide applicability of OCI Plus.
And maybe I'll just give another example, TJ, that builds on that. We use the same we use pieces of our OCI plus modeling approach because RMI is also a participant in the Climate Trace Coalition, which is modeling global emissions from all anthropogenic sectors. But we are contributing oil and gas, and a big part of this is oil and gas methane. So when all of these models, RMIs included, are combined in the trace inventory, you're getting a more complete picture of all of the different methane sources in a country, and a policymaker could look to a tool like that to kind of see how it's partitioned and where to focus methane mitigation efforts.
Great. And I want to turn a little bit to the market side of this, because oil and gas are obviously, to my mind, money in another form. They trade like this. And this year, actually, the global gas market is poised to cross $1 trillion of trade. I mean, it really is going global. So I'm curious, TJ, how the underlying models in the OCI Plus can be employed to inform oil and gas trade.
Yeah, it's a great question. And it's a really fascinating area. Actually, there's been a lot of interesting developments in the last few years on this front. Sort of at the highest level, if you're thinking about what OCI Plus brings, right? It's open source, objective methodologies, underpinned by these models, and that provides a lot of value, especially in the form of transparency, which is essential to a well-functioning market. And for price discovery, as we say, sort of in economics or market speak. So I'll highlight two examples. One example is in price reporting. So we have some pretty important price reporting agencies, especially Platts, which is part of S&P Global, and it leverages both OPGI and Prelim to make carbon intensity assessments. These assessments started out and were launched in sort of September 2021. And there are two metrics, one for crude and another for refined products. Platts sees emissions intensity as an important and growing attribute, kind of like API gravity or sulfur content or other things that you might see on a crude oil assay. And that is, I think, what is going to be increasingly the case over time, is that this will factor into pricing and contracting. And we actually put out a piece of analysis on this just in the last week around sort of the GHG intensity of benchmark crudes, leveraging OCI Plus. So I would encourage everybody to take a look at that. So that's one example. And another example is the use of OCI Plus in something quite different, but very interesting and potentially significant in the coming years, which is to help inform how to shut in oil fields, maybe even before the end of their economic lives, if there is value that can be generated from that, let's say in the form of an offset, right, in a voluntary credit scenario. And the idea here is that if you have a third party that's willing to pay a producer to shut down that field early, then that might actually provide sufficient incentive to decommission a field ahead of schedule. But what's essential to that is to fully understand all the emissions that would be, essentially left in the ground, right? And you need robust modeling, transparency of the inputs that you're using, and that's precisely what OCI Plus does best. So it's just another fascinating example of where we can see OCI Plus having direct impact on not only emissions transparency, but also reducing emissions and even maybe shutting in certain fields earlier than economics might suggest.
And shifting to specifically banks and financial actors, TJ, how can they use the OCI Plus in all that they try to do, both in terms of lending, but also in terms of energy transition planning?
Yeah. This is another great question and interesting topic. So banks and other financial sector institutions, like other companies, have set emissions reduction targets, and they're developing methodologies to make climate-aligned portfolio decisions. One example that has been publicly available is Barclays Blue Track methodology, which aims to establish climate-aligned portfolio benchmarks, quantify customer and client emissions, and then link those emissions to financing and portfolio decisions. And as part of that methodology, assessing or evaluating the emissions intensity by fossil fuel is really key. And here again, OPG and Prelim, two critical models underpinning OCI Plus, are used. Similar approaches can be taken with other banks and are being taken, as I understand, with other banks and asset managers, but also insurers and reinsurers. And we have used or worked with Munich Re over the past few years, just to help them take advantage of OCI Plus data and inform them of climate-related risk. So, I think OCI Plus as a tool and a methodology can be widely used. And then I think our team's capabilities of understanding these tools are equally important in some of this potential use cases in the future.
And last question before we open up to Q&A that Linda will run, and just a reminder for folks to add any questions you're thinking of that come up into the Q&A function. But for both of you, what current and future opportunities do you see for oil and gas companies and policymakers thinking out, to use the OCI Plus?
Thanks, Debbie. I can go first and quickly. I know that I've been talking successively in the last couple of questions, so I'll pass it to Fran pretty quickly. But one of the sort of key trends in emissions transparency, in addition to really significant advances in measurement and modeling, is also corporate disclosure and target setting as part of that, sort of as being of a piece with that. And one aspect of this is that there's growing recognition that emissions factor-based approaches are not sufficient. And so the incorporation of more measurement and rigorous modeling into this type of disclosure, I think, is a really interesting area that is advancing. And I think what that will allow is sort of this interplay between the modeling and measurement and corporate reporting, and then also using that work to then assess companies' performance against their emissions reduction targets. So it's not just a sort of what happened last year, but it's what's happening now and what might be happening in the future. So I'll pass it to Fran to talk a little bit more about the policy side.
Yeah, and I'll just pick up where I left with some of the policy aspects, but I keep coming back to current opportunities in front of us. It seems like in many ways, again, at least in the US, we've made significant headway with some historic methane-related policy movements, specifically through IRA and the oil and gas rule. But I think there are a lot of open questions still about how, what are the nuts and bolts? How are these policies going to be really implemented and applied? And questions that policymakers are facing, for example, how will intensity, which ultimately underpins the methane fee, be calculated? And how are we going to move towards, improving reporting programs and inventories that these programs are ultimately based upon? And how do we start to integrate measured and modeled sources? So I think a lot of these lessons learned and questions we've been working through the OCI are applicable to settings like that. And I think this also, extends to the state level. There's a bill going through the California Senate right now that is considering the state to procure certified low methane natural gas. And so again, I think this raises questions about how can modeling approaches inform how to create well-designed policies.
Great. So let me invite Linda and Rose back, and let's see what types of questions those attending have come up with.
Yes, thank you to the panelists for this discussion. We have had several questions come up in the chat, and I'll encourage people to type in additional ones as we speak. We'll try to address as many as we can, and the ones we may not be able to get to in the next 20 minutes or so, we'll try to get back to you directly with our answers. So please type your questions away. So the first question to start with, I think Fran briefly touched on this earlier, but the question is, can satellites detect methane emissions from venting? There has recently been efforts to restrict flaring, but if unwanted methane is vented instead, CO2 equivalent would be much worse. So perhaps, Fran, if you could expand on your earlier commentary related to flaring and venting.
Yeah, sure. And apologies for focusing. I focused more on the flaring aspect of that earlier, but for the other part of the question that's related more to can satellites detect it? I think the short answer is yes, with some caveats being, at least for satellites that are designed to measure what we call point sources or really strong concentrated sources of methane, such, most venting sources would qualify as a point source. It has to be large enough to meet the satellite's detection threshold. But I think even more importantly, the satellite has to be overhead while the venting is occurring. So this gets to the need for constellations of instruments that are doing high frequency monitoring of the Earth to give them a higher probability of detecting even those sources that are intermittent. One day they're there and a few days later they're not. And so it's all about being in the right place at the right time. And constellation satellites increase the probability of detecting venting.
And Linda, I was just going to add that there was a commentary that we put out on a science article with Riley Doran from Carbon Mapper. And it turns out that globally a lot of flares operate unlit, which means that they just are a pipe that's venting gas, sheerly venting gas. And even those that are lit are often really inefficient because they're not maintained. Many flares are in remote locations and the weather conditions are bad. Offshore is really difficult to get to the top of a flare stack. So being able to use satellites to figure out when methane is being vented from any equipment, especially from flares, from storage tanks, from high emitting sources, is going to be critical information from satellites.
Thank you, Debbie. Thank you, Fran. The next question that has come in, how have RMI's ratings for facilities or operators changed as related to improvements in monitoring technologies and the EPA's recent draft of supplemental methane rules? And I'll let whoever would like to pick up this question first.
I say Fran because she wrote comments to EPA.
I can start. My gut tells me that at least right now, I'm optimistic, but it's a little too early to tell exactly the full effects and for the latest drafts of EPA action to be, the fruits of the labor to be seen and to be fully reflected in the modeling. I think an important element of this is as monitoring technologies improve, we're probably likely to see more methane than we maybe even knew was there before. It's revealing these really high emitting, super emitting sources, for example. So I would expect our estimates to, in the near term, go up, but with effective action taken by EPA and others, I do expect them to go down, hopefully several years after that.
Thank you, Fran. Another question was related to our plan for distributing information about OCI Plus, insights from OCI and other associated reports to federal and state policymakers, as well as national and local media. So to the panelists, can you speak a little bit about our plan for this?
I could start just because there's a long history here. It's not, RMI is vastly expanding this, and we are now re-releasing 2022 data, as Rose said, after in June having 2020 data. So we've included several more years and many more assets. So it's been a rolling effort, and it's actually been a rolling effort since its early days in 2015. But I can give examples of policymakers that are already picking up on it, which I think will help underscore the breadth of the decision making that goes into oil and gas. So we've been talking to the International Energy Agency. They featured this in the World Energy Outlook in 2018. This is the supply side of oil and gas sector emissions. And they're using these models to do the next World Energy Outlook, and we work really closely with them. TJ mentioned Resources for the Future. Another NGO has used this in a major study that they just published. Sat down years ago and rolled up sleeves with the government of Norway and talked to them about their emissions and Equinor, and how Equinor's emissions were lining up between reported and estimated emissions. Definitely have sat down with companies in the past and several financial actors. tried to get the Department of Energy, the US Department of Energy, to be more transparent so that we could get better inputs for this data. The US is one of the most complex oil and gas spaces in the world to get disaggregated data. It's really hard right now for the federal government to require companies to give out activity data. So we're really looking at the competitive nature of this industry to instigate that type of the transparency that we need for the models with the backing of the government. It's more of a government follow and an industry lead there. And I don't know, Linda, if you have any other ideas, because you do corporate engagement as well, feel free to answer.
Yes, we're certainly trying to, through webinars like this, through individual one-on-one briefings we're doing with a number of actors, is to share the information about OCI plus insights that we have. And we're also open to deeper conversations and explorations with interested parties. So feel free to reach out to us. Happy to chat more. And thank you, Debbie. So we had two questions related to abandoned or orphan wells. One is how much methane leakage is coming from abandoned wells, and also sort of what information can OCI Plus provide as it relates to emissions from orphan wells.
I could kick off. And I don't know, Rose, if you want to answer, or Fran, in terms of the models. So the models are they're very detailed in terms of operations. So whether you're operating well or poorly, or even shut in, as an abandoned well would be, you can actually model these things. And I did model a blowout in a well, which is not an abandoned well. It's a different type of operations when there's a catastrophic failure. And I modeled an Eagleford blowout in 2019 that the satellites detected. And what I modeled from the estimated emissions and what the satellites detected were almost perfectly reconciled with each other. And I think it surprised both us, as being those that modeled, and also our partners at Carbon Mapper that were doing the satellite detection on this. So if you know anything about the reservoir, you can model an abandoned well. You basically are trying to see if it's not if it's shut in, so it's not producing, but it is still, the reservoir has motion in it, has movement. You can do that. The other question is, how low is the leakage? Because, and Fran might know better than I do, if an abandoned well is easily picked up by a satellite. Now, a region of abandoned wells, an entire area of an abandonment, might be something that you can pick up. I don't know what you think, Fran.
I think that's right. Not to use too much specific terminology, but we generally think of two types of methane sources, either as a point source, which, as I mentioned, is like a very concentrated, very strong signal coming from a pretty well-defined area. And the complement to that is a diffuse source or an area source. And generally abandoned wells, lots of them located over a broader region, are considered in the second bucket. So it takes a specific type of monitoring to be able to detect the methane that kind of seeps out of them. And yeah, I don't have a specific answer to the question, because we tend to focus our modeling on active production operations and not looking quite so much as at abandoned locations. But while I'm thinking about it, the other really useful part of the modeling approach is actually forward-looking too. Don't know that we've gotten to mention that, but it fits in this, it fits in the theme of complementarity between measurement and modeling. You can't measure something, you can't fly over something with a satellite that hasn't been constructed yet or put into operation, but you can model it. So just another way that these two things go hand in hand.
Yeah, and I also want to add that for orphan wells, it might make more sense to use like ground-based sensors to measure the exact emissions from those wells. And because they are abandoned and nobody actually owns it or owns the outcome of the emissions, that will make sense to create a voluntary carbon market so that money from the third party can help stop the leakage or stop the emission from those sources immediately. While I do think, voluntary carbon market might not quite make sense for the big oil industries who owns lots of aging wells, because it's a big industry. They profit a lot from those wells already. So, but maybe, people have different perspective on this too.
Thank you, Rose, Fran, and Debbie. The next question, I believe, touches on something that TJ referred to earlier. So maybe I'll ask TJ to respond. Why should third parties incentivize an industry that made a $4 trillion profit last year?
Thanks. I believe that this is in the context of shutting in oil and gas fields. And I think that what I was trying to explain, and Debbie directly referenced sort of the resources for the future. We just jointly put out a paper around some related topics here, but there is the possibility that we might be able to shut in oil and oil production in the near term, and construct sort of incentives that would allow for that to happen. But to do that, you have to be very careful that you don't incentivize other production coming online, or more emissions being, in other words, more emissions being emitted somewhere else. And so a lot of the sort of challenging economic questions are around preventing that or minimizing that, so that the net effect is reduction of supply and reduction of emissions. And that can be an important lever to consider if our priority is to reduce greenhouse gas emissions as fast as possible, and the role that oil and gas in particular play in the energy system.
Hey, thank you, TJ. The next question, we've got some requests on more detailed information around how to use OCI Plus. I think we had a demo by Rose, and again, we're happy to do more in-depth conversations with those who are interested. So I would recommend anyone who is interested in getting in the deeper details of OCI Plus with us to reach out, and we would be happy to dive deeper. I will go to the next question that is related to government decision-making. How can information provided by OCI Plus be used to drive governmental decision-making, either agency or regulatory action or legislative action at the US federal or state levels, or even international levels?
Debbie, do you want to expand on any of the examples I started to give?
Yeah, I think that would be helpful. Mm-hmm.
Sure. Right now, the greenhouse gas reporting program at EPA is a good example. And this is true of inventories around the world, many of which are extremely old. And we found this in our climate trace work. It's self-reported data that often use very simple emission factors. So they take a volume and they multiply it by a number, and that's the emission that they will report to an agency. And the idea behind the OCI Plus is that if you know more about these assets, given that slide I showed you about how wide-ranging, and the industry impacts, the upstream industry impacts are like a factor of 10 difference between the lowest and the highest emitting, and sometimes more than 10x. So there's huge opportunities to disaggregate this industry and understand where the emissions are, what's driving the emissions, even in an individual supply chain. And don't waste time and energy, because everything has an opportunity cost. Don't waste time and energy not going for the things that have either the lowest hanging fruit or they're a really big bang for the buck. And I think that we shouldn't expect governments, global governments or state governments, to be experts in industry, whether it's oil and gas or any, landfills. We're working on landfill methane. That we really, the NGO community, can be a really big help to the government to kind of translate between what the industry and what we've done with the OCI Plus is an example, and then helping the government do better what it does really well, where to regulate, how to price. The global methane fee, the methane fee in the Inflation Reduction Act is an amazing example of transformation. This is the first carbon tax the US has ever, as a nation, passed. And so we have shadow prices, as Rose was showing you in the OCI Plus, to give a better sense, to keep that reported emissions, keep it open and honest and transparent, so that there's a fair share being paid in of these competing companies under the Inflation Reduction Act's methane fee. So I think that this just undergirds everything data-wise and detailed, and the world is so digitized and data forward these days that this information just makes government operate at all levels much smarter.
And I'll just add to that, Debbie, another sort of body or agency that has kind of been charged with thinking about this is this interagency working group that Biden put together, and then they just released a draft strategy in January, I think it was. So we've been providing input into that with all of the things Debbie is saying, is how can you set up a system that is really tapping into the knowledge that lies outside of government, lies with third parties, and lies with other actors who can really contribute to the mission.
Thank you, Debbie and Fran. And this is maybe kind of an extension to the previous question. How could OCI Plus help inform the presumed underestimation of oil and gas supply chain emissions by EPA? And can we, through OCI Plus, estimate any underassessments based on our data?
I can start on this. If you're familiar with the Jeff Rutherford study that was titled Closing the Gap, and it basically addressed the ability to identify what are the exact sources in the EPA reporting and inventories that are responsible for that underestimation. Jeff is one of the main authors of the models that we at Stanford, or the previous Stanford PhD, that we have incorporated into our work. So short answer, yes, we can look at some of the underestimation and look at some of the sources that happen to be focused on tanks, for example, and fugitive emission sources. So, and then I think the other thing that will come increasingly into the fore, again, with the integration of the super emitting data from measured sources, aerial, satellite, and others, we will get a better and better sense of our assessment of what those underestimated sources are when it comes to methane specifically.
Anyone else? I thought that someone else was coming off mute earlier. Okay. One question that has come up related to methane emissions is just simply what proportion of methane emissions come from oil and gas?
Yeah, so in the US, and the US is different than national statistics. I was just putting these together. In the US, it is currently estimated about 1/3 of the methane, human-made methane. There is natural methane as well from swamps and wetlands and melting permafrost, et cetera. But of the human methane, about 1/3 comes from oil and gas, and globally, it's estimated to be closer to 1/4, about 25, 26%. But there's a really big asterisk there for me, because I do think that we don't really know the size of the pie, the size of the pizza pie of methane, or the relative slices. And that's what the satellites, this whole constellation that Fran was talking about, is really going to illuminate for us, making methane visible. And there was another question I'll add to this. Until now, methane is invisible, or has been invisible over water, because the reflectivity of the water interacts with the detection, the instruments that detect the methane. But Carbon Mapper and NASA have figured out how to come in at the right angle that they call glint mode, that they can actually measure methane over water. And I showed a couple of pictures of satellite methane that was leaking. Clouds, for all atmospheric measurement, clouds remain a barrier that you can't see through a cloud.
Any other, just to kind of respond to that question you referenced, Debbie, just for the audience, it was related to what are the limits of some of the satellite data. Debbie obviously mentioned clouds. Are there any other limits that the team would want to note?
Yeah, I'd also like to add the intermittency nature of satellite observations. Like for several satellites that we are using their data for, they could be like looking at a specific place for a limited amount of time and observed a few plumes for the entire year, which makes it quite challenging to arrive at an annualized number for those emission sources. So as Fran was saying, having a constellation of satellites, the more the instruments are there looking at the Earth from various different angles to get a holistic picture from various different sources, the better. Offshore sources, I think that Debbie has covered it. Like Carbon Mapper has a special mode where they can actually see things from the sky on the ocean. And I also want to say that, highlight a tool that my especially friend has led to develop called SPECT, SPECT, and it's about highlighting the different functionalities of different satellites and see which satellites are having the specific resolution that you can use for a specific task, and what are the different coverages of the different satellites. So that tool is very useful for helping us understand the limits of different satellite systems and how to overcome those limits by combining data from different satellites. And
Okay,
Fred,
and
also say more.
Oh, go ahead. Sorry. I was just going to end on an optimistic note, which is that while we are, there are some obviously some limitations or challenges, there's actually a lot of really interesting work in trying to synthesize all this data so that it can be used in a wide range of different ways. And that some of the most fascinating sort of science and technological developments are in that space as well, not just in the measurement part, which is also fascinating, but also in the synthesis of that data. So that's an important space to keep watching. We're doing more work on that too.
And to put a fine point on that, what TJ was saying, we're using our knowledge and process for having developed the Oil Climate Index plus gas over the last decade into replicating this type of a mapping tool and measurement tool for waste methane, for landfill methane. So not that dissimilar of a space in terms of, instead of the oil being underground and the plants rotting, the garbage is on top of the ground or in landfills and rotting, and it's another major source of methane.
Mm-hmm. Okay, thank you. We're coming to close to our final time. I'm going to ask one more question before turning it over to Debbie for her final remarks. Just wanted to note one other thing. We've received a couple of questions in the Q&A whether we will make the recording available. So I just wanted to address that we will. We are all participants in the webinar will receive the recording in the next day or two after we close. So you will have the full information. So the last question I'm going to ask quickly in the next minute or so is whether based on our models, we can get carbon offsets from orphan and abandoned wells, and are emissions enough to generate those offsets? So kind of going back to the orphan well question, but with a specific angle of carbon offsets.
I can take that. First of all, I would point to actually the Inflation Reduction Act. There's a lot of money that will be used, hopefully, to shut in some of these wells. And in instances where we have a regulatory and policy approach to shut in, especially orphaned and abandoned wells, I think that is optimal. Second point is that when it comes to generation of offsets, often you need sort of a party, an operator to be on the other side of a credit generation, right? So it's not necessarily the best sort of incentive alignment for trying to shut in an orphan well if you don't know who is responsible for it. So what's been more of a focus have been marginal wells that are maybe high emitting, but have a direct producer, or even full fields. I think we could see some larger fields being shut in this way, and so that would be my short answer to that question.
Okay. Thank you, TJ, for that. I think with that, we're going to conclude our Q&A with the audience. I want to thank the webinar participants for very thoughtful questions. We did not get to all the questions we've received, so we'll follow up on those afterwards, so you get your responses. And with that, I'll turn it over to Debbie for her closing remarks.
Great. Thanks, Linda. And thank you all for joining. It was great to see the questions and coming from so many different perspectives, which really underpins what we think about this sector. It touches everything. RMI's overarching goal has been to make oil and gas emissions visible to drive transparent climate decision-making, and we're really excited to get this information into stakeholders' hands. In the year ahead, we'll gear up to expand the model, get more granular global oil and gas asset data, expand country coverage. I'm excited about this, but adding economic and environmental justice metrics to the web tool, incorporating methane satellite data as we've been discussing, and displaying owner and operator data in this. And we're really eager to hear from you. Please don't hesitate to follow up with us if you have ideas for use cases. We really welcome the feedback. And thank you very much for joining. Take care.